Welcome to this video on the topic of vectors. In this lesson, we're going to have a look at the different ways in which we can represent a vector algebraically. Vectors may be represented algebraically in at least two forms, that being component vector form, and secondly, unit vector form. Now for the first one, we have component vector form. This can come in two varieties. Consider we have the vector u. Vector u might be defined as, let's say, -7 and 3. This form over here is component vector form. It's defined as having the two square brackets, and then we have upstairs a number and downstairs there's a number. The upstairs number represents the x value, and the downstairs represents the y value. Moreover, this form over here, I often refer to it as a column vector. And I call it a column vector because the vector is arranged in a 2x1 matrix, so it's a column of numbers. Now the other way in which this can appear is it could be defined as a row vector. Now the row vector looks very similar to a point in space. However, notice the key differences. It's done with square brackets, but you can do it with parentheses, but there is no comma between the numbers. So this still represents the x value, this still represents the y value, but this is in the row vector form. Now in South Australia, for our high schooling system, we typically don't put our component vectors in row vector form. We try to keep them in column vector form. There's no particular reason why, it's just what we do. So it's really rare that you'll see it in here, but in the case that you do see it in this form, you are allowed to simply switch it into that form over there. So these are component vectors. The second form that you might encounter if you're doing SACE is you might have the unit vector form. Now the unit vector form is very similar to the component vector in the information that it I guess you could say communicates, in that we could have vector u and it still could have -7 and 3, but rather than writing it as a matrix, we write it using I and j, where this represents the x value and this represents the y value. The value for I is simply a base vector for the x values and j similarly for the y values. So the cool thing about this one over here is you're not having to write things as a matrix, rather you can write it using algebra, so I and j, so where you're collecting the like terms of I and the like terms of j. So the coefficient in front of the vector I simply represents x-axis, and the coefficient in front of j represents the y-axis. So these are the two forms that you will typically see vectors represented in. Now let's have a look at how we can convert between the two. Suppose we have A, and we'll say that this is -10 and 7. Suppose we want to convert this into its alternate form. We know that this vector is in component vector form, so the alternate form is unit vector form. So the way in which we do this is we just go -10. -10 represents x values, so this is going to be I, plus 7j, because the 7 represents the y values. So that's your first conversion. Now the second one we could get, let's go B. Suppose we have vector B is equal to 3i plus 2j minus, let's say, ki. So we spice it a little bit. Notice that we have two i's, so these are like terms, and a j. We want to convert it into its component vector form. First thing we need to do is collect the like terms, so it's going to be 3 minus k I plus 2j, and then putting it into its column vector form. The x value is 3 minus k, and then we have a 2 over there. So you're going to find that the column vector here is 3 minus k, and then there's a 2 over there. So this is the component vector form. We've gone from unit vector form to component vector form. So in summary, what we had a look at in this lesson was that we can represent vectors algebraically, where we have a choice of two forms. We can do component vector form, unit vector form. Component vector form could be done as a column vector, so a 2 by 1 matrix, or we can do it as a row vector, which is a 1 by 2 matrix. The unit vector form uses the base unit vectors I and j to represent it as an algebraic expression like so over here.